Be good. Okay, welcome to second session for Global AI Day local edition in Malmo. Our next speaker is joining online. It is not pre-recorded session, it is live session, so we can ask questions at the end. And our speaker is Abu Karali from NVIDIA. And we will hear some exciting things about NVIDIA Metropolis and Microsoft Azure. So welcome, Abu. Stage is yours.
Thank you. I'm pleased to be with you. I wish if I could come to the south of Sweden, but that wasn't possible this weekend. So yeah, so next time I think it's going to be better. My name is Abubakr Karali, and I go short by Abu. I'm based in Stockholm, and I work as a new solution architect in intelligent video analytics, which is another way of saying I work with computer vision for our customers. I support our customers and partners across Europe, Middle East, and Africa, mainly supporting them during training and also optimization and the deployment of their computer vision stack and machine learning workload in general. I support tools like Metropolis, and Metropolis consists of, I don't know if you have heard about these things before, Deepstream, TensorRT, Triton Inference server, TOOLKIT, and Fleet Command. That's me. I've been in NVIDIA for 3 years so far. Before that, I was part of Microsoft research and also research in Sweden. That's me. So today we're going to talk about how can we train and deploy with Metropolis tools on Microsoft Azure. So if we started, we're going to talk mostly about computer vision, because computer vision has been everywhere. You can find it in a smart city application, you can find it in retail applications. Right now, it's also a major part of healthcare. Also, it's booming with robotics. All of this is because of the low cost of the sensor and also the amount of information that comes out of the video sensor. Basically, you can see everything with your eyes. You can have it on a computer. So the main idea here is how can we automate things or some tasks of what we can do with our eyes into our computer. And with that comes a lot of application, as we said, in these sectors, also video conferencing, call centers, industrial inspection, and retail systems. So all of these applications has been booming in computer vision. It has been there in research for a while, and right now it has been, for a couple of years, has been heavily industrialized. So the process of taking computer vision from the research area to the application domain, where you should care more about which model and how can we deploy it for real, how can we make it fast, and how can we make it reliable, is quite a challenging task. So if you are a developer and you're developing your computer vision pipeline, starting from training to deployment and managing your deployment, you have a lot of challenges. So starting with how can you collect data, what is the right amount of data to train your model. Also, you have multiple frameworks. You have, for example, TensorRT, you have TensorFlow, you have PyTorch, you have MXNet, a lot of software tools. So you need to educate yourself in so many tools as well if you want to start with. You have lots of architecture as well. You need to choose from which architecture is suitable for your problem and which architecture is suitable for your data as well. Then after you do the training, there's several steps for optimization as well. How can you make your model faster? Does the tools that you have chosen in the beginning allow you to do something like quantization, where you can quantize all the mathematical operations, or something like pruning, where you can cut all of the leaves that doesn't contribute that much in the computation of the decision. And also you have during the training something called quantization aware training, does your tool have that or not? And then finally, you end up with a model which is trained on the data set and also optimized. You then push it forward to deployment. And for deployment, it's not only about the model itself. The model is the heart of your computer vision application needs. But deploying a model consists of interfacing with the camera, decoding the stream from the camera, pushing it forward to a pre-processing stage, and then push it to the model or the classifier that you are having, or the detector. And finally, how can you integrate all of these analytics that you get from your pipeline into something bigger? How can you gather information out of this analytics? So basically, you need to integrate with something else. And also you need to manage the deployments. So all of these challenges is there when you are trying to move computer vision application from a research domain, from the proof of concept domain into production. And these are challenges that you can find if you're going to start with computer vision for industry. And the solution here we provide is NVIDIA provided something we call Metropolis. NVIDIA built something we call Metropolis. So Metropolis is an ecosystem. It consists of hardware and software and also partners bundled together to provide you with the best practices to start with computer vision applications in industrial setup. So if we started with a base here, you can find the Jetson appliances, EGX server, and clouds. What's main is basically the Metropolis ecosystem supports all the Jetson devices, which is our embedded devices. So basically, you can have embedded devices somewhere with this. You don't have to have like a full workstation or computer. Then you have the EGX server, which is a server that has either discrete GPU for server installation or a discrete GPU for workstation installation. So it depends on the architecture, whether you are deploying on a server or a workstation, Metropolis would work. And also, regarding also this session, we have also support for cloud. So you can start a virtual machine and start your workload on that virtual machine as well. So Metropolis works on a hardware level on all the platform. It gives you a variety of everything. And on top of that, you have the normal NVIDIA decoders and NVIDIA software stack. On top of this, you have the CUDA-X, which is our accelerated libraries for machine learning workloads and deep learning workloads. It consists of CUDA for high performance computing and CUDA DNN for accelerated deep neural network application. Starting with that, these are the base layer, the foundation layer of our software. Then we go to more specialized toolkits here, or libraries here. I think one of the most downloaded library that we have at NVIDIA, TensorRT, is very popular. It's a runtime engine, and also it's an optimizer. So your model can run directly on TensorRT, which also does a lot of optimization operation for your model. So you can do something like quantization. You can also do layer fusion. You can also do loop elimination inside the network. So a lot of optimization that can speed up the model on the runtime. And you also have Triton Inference Server. And Triton Inference Server here works as a server client application. So basically, you can house your model into Triton Inference Server, and then you can call it with HTTP, you can call it with gRPC and API calls. So it transforms the problem of hosting a model into a client server application or architecture. On top of that, on top of all of these libraries, we have what we call, we have the NVIDIA Metropolis software stack, which is a software stack that facilitates the process of training and deployment. So when we talked about the lower level libraries, it was mostly about accelerated libraries and also accelerated runtime engine, which is only a runtime engine for the model. But on the top layer here, you have a complete software stack that takes you from nothing to the market. It's an end-to-end platform. Here, with the models, with a module marked in white. So basically, you start. The white here marks the building blocks for the training, and the black here is the building block for the deployment for this division. You can see that you can start with pre-trained model. That's what we offer first. You can go to an NVIDIA GPU cloud, which is not a cloud, it's an online repository. And you can go there, you can download a model, you can find different models you can start with. Then you can use TOOLKIT, which is our training toolkit for deep learning training. It works on speech and computer vision and text processing as well. So basically, you can start with a pre-trained model from NVIDIA NGC, use TOOLKIT to train and optimize as well. And finally, you can deploy with Deepstream SDK. Deepstream is a pipeline acceleration tool that we will discuss later. So that's our tool for deployment. And video codec is also one of the popular tools that has been used in decoding the streams. All right, so how can we start with that? How can we make a formula out of that if we want to start from nothing right now, we have a problem formulation, and we want to end up with a model or a computer vision pipeline? First thing, this is a typical workflow for how can we start with Metropolis. Usually you go to NGC, you download a model, or you can come right now with your own pre-trained model, and you can start with your own weights. This feature is new, so far it supports only classification model. But right now, the workflow starts usually with optimized model that you can find on NGC. Then you use TOOLKIT for training. That works on everything, including workstation, cloud, and DGX systems. And then you push it to the production with Deepstream or Triton Inference server, and you can manage it still with edge to cloud application. So something like Azure IT, for example, you can manage multiple devices with. So a pipeline like that can guarantee that you have high accuracy and faster time to market, and also highly optimized pipeline, as we're going to see later. If we started with the first building block here, the model selection, or how can we start? What are the available models that you can find? Let's go directly. We have wide range of application, wide range of models. So if we start it here, so we have wide range of models. The models that you can find on NGC decompose into two main categories. The first one is purpose-built models, which is built purposely for an application, something like face detection or gaze detection, body pose, license plate detection, something very specific like that. Or you have the generic models, and this is the second category. The generic models is, as you can see here in the slide in front of you, it's a model that has been trained generically on a data set, and it doesn't have a specific, well, it has a specific task, but its task is very generic, like, for example, classification of 500 classes or something like this. This is the support matrix that we have right now. So basically, you can find models for image classification, model for object detection, and model for segmentation. For example, with object detection, you have different kind of object detectors running against different kind of backbones as well. So this is a support matrix. It increases every time we have a new release, every time a model has proven to be efficient in the literature, you can expect it directly in this support matrix. And these models have been trained on both available, publicly available datasets and proprietary NVIDIA datasets. We guarantee that it matches the state-of-the-art, if not better. And also we guarantee that it's highly optimized models. If we had a second look or a first look here on the purpose-built models as well, you can see that we have, these are examples. You can find more than 15 applications on NGC. These also the performance that you can get. So basically you have also the performance indicator of each model across different kind of hardware, starting with A100, which is a very powerful server installation card, and goes to workstation installation card as well, and the Jetson devices, including our latest Jetson Orin. As you can see here, Jetson Orin is very powerful. Actually, it's also almost half of A10, and it also matches our traditional T4 card for computer vision. So yeah, so that's what we have here. Also, we have, as we said, highly optimized pipelines. So when you usually use TOOLKIT for optimization, you end up with much faster model, as we're gonna discuss why. So this is regarding the selection of the model. All right, so we are 15 minutes, so I need to speed it a little up. So the second part here is training with TOOLKIT. TOOLKIT, as I said, it's our training platform. You can use it on workstation, and you can use it on a cloud, and you can use it on a server that you have in your office. So it's offered you a wide range of features, starting from the beginning with the data. It offers you a data augmentation toolkit, so you can augment your data with different kind of very basic and efficient data augmentation techniques, something like blurring, special variations, and also color changes. Horizontal flips and shift and zoom and rotate, all of these operations are supported. It's a very simple operations, but it's also very efficient when it comes to computer vision. The main idea behind TOOLKIT is to start with a model that's already pre-trained. So the main idea of TOOLKIT is actually transfer learning. So by transfer learning, an easy task that you can do is to adapt your model to a new data set. And by that means, with TOOLKIT, it's very easy to change the viewpoint of each camera, for example. So if you have a model that's trained to detect people from PeopleNet model, for example, from it looks like a dash cam, you can switch it easily to like a different kind of cam, and basically train it with thermal data, for example. You can also add new classes. If you have vehicle detectors, you still can add an ambulance as a class if you collected like very tiny amount of data. So these are quite known for transfer learning in general. So I think it's very easy to grasp, but also one of the very key features for TOOLKIT is optimization that you can do to the model. So the first optimization here I want to mention is the pruning, because pruning is very, very efficient technique. It can get the model 10 times smaller in memory footprint, and also you can get up to like 2x speed up in the performance. And that's because a lot of the nodes that you can find inside the neural networks are zeros. So by cutting off all of these zeros, you end up with a much faster model. Quantization as well. So TOOLKIT allows you to do quantization-aware training. So basically, you can train your model while you are aware that you are going to do quantization later on. So basically, you compensate for the errors that will happen when you do quantization. And also, it allows you for automatic mixed precision. So you can do highly complex operations when you need that, and also it will simplify the computation for you if you don't have it. So layers like the loss layer and the summation layer and the exponential are heavily it requires heavy computation, so it's going to be done on floating point 32, and something like convolution and I don't know, would be matrix multiplication will be on floating point 16. So it automatically adapts for your workload. And finally, to mention here, it also supports different kind of deployments. So you can have it on your own workstation. You can also have its own different clouds, and we're going to see how can we work with Azure if time allows. So that's regarding TOOLKIT. I'll start to speed up a little bit. And we're here. Yes, so that's regarding TOOLKIT. So the third part here is the application or the deployment. So right now we started with a pre-trained model, we fine-tuned it and maybe did some optimization with our own data and to our own model. And right now we end up with a model. How can we deploy this model? So as we said, deploying the model is not only about running a model. So basically a deployment consists of a whole pipeline starting from camera. How can we capture the stream? How can we push this stream and patch it and pre-process it? Then we push it to the inferencing and do some maybe tracking if we did detection. And also we gather some business analytics. And finally, we can store it somewhere or send it somewhere. So a deployment is not only about the model, it's about a whole pipeline. So accelerating a model only will not be useful. For example, if you have a decoding bottleneck, or if you have a networking bottleneck, or if you have a pre-processing bottleneck, you might end up with a much faster model than your capabilities in other part of the pipeline, which is going to be a blocker. And that's why we have introduced Deepstream. So Deepstream basically accelerates all of these boxes on the GPU. So you start with capture and decode. The capture and decode happens on the GPU, on the specific hardware of the decoders. Then you push it to pre-processing, which sometimes happens on the GPU, and also you can monitor that with the CPU as well. AI inferencing, which happens on GPU and the deep learning accelerators part of the the Jetson devices. Then tracking and business analytics on the GPU and the CPU as well. So all of these pipelines are accelerated together to make it easier for you, and also to give you like a lower to have a look at the lower level here of Deepstream. The frame of the GPU, the frame of the stream doesn't leave the GPU at all, and also the memory transfer between the CPU and the GPU is minimal, and between the is zero, and between the GPU and the GPU is almost minimal, because the frame doesn't move. It's only the pointers that move across the pipeline. So when you capture, you create an image, and basically later on it's only the pointers that are being passed on. And Deepstream offers you also with different kind of options for deployment. You can start with Python, you can start with C++, and also you can start with a graphical user interface with zero coding options. And one of the major features that we have here is a cloud integration. So cloud integration is one of the major parts here. With a custom parser, you can process the data and basically send it with MQTT to any MQTT server, something like Redis or something like Kafka. Yeah, I'm sorry about this text that was up. Or Azure IoT, for example. So all of these cloud integration is supported. So, okay, so how can we put all of these together on Azure? This is our supposed pipeline here. So we're going to start with a model from NGC. We're going to upload it to Microsoft Azure, and we're going to start a virtual machine for Tau, and then basically we're going to deploy as well. So Microsoft Azure offers you with different kind of GPUs. As you can see below, you can see that NVIDIA T4 A100 are available. A10 is available as well, and you have IoT integration with JSON devices. This is a closer look on the virtual machines that you can find. So starting with NC, which is heavy computational ones, it's very, very powerful. And you have the ND, which is, the NV, which is very light, the one in the bottom section here. This is a lighter version. And also the ND, which is very powerful machines. All right. So how can we start? So if we have chosen a virtual machine like that, how can we start with? Still, we have 4 minutes. How can we start with? NVIDIA offers you with a with a GPU optimized virtual machine. You can find it on the NGC, on the NGC as well, and also you can find it. I don't know. Yes, the video is working, and also you can find it on Azure as well. So if you want to start right now your own virtual machine, basically you would do that. You're gonna create a resource and you start a virtual machine. You give it a name, and for example, you put the name of the machine and you select a group name. I don't know how to accelerate this video. No. Oh, no. All right. So basically, this is how it works. You select. Sorry. Yeah. So basically, you create a machine, and then basically you select this virtual machine from the Azure catalog, and then it will start a virtual machine with you with the GPU, and also you will find the recommended machines, which one should work better with this virtual with this image. So as easy as that, you also can find in the model card here or the image card which models are supported and see it works, for example, with NC version 2 and NC version 3 and all the ND series. Yes, and here you select the zone. Here is in the video right now, you're selecting the model as the image. You cannot find it in the short code here, so you can go inside all the images. You can search for NVIDIA, and it will show up on the first option. You select which version, and then basically you create that one. So once you have created a virtual machine, you're gonna need to start working with your virtual machine here. So the first thing is you will SSH to this machine, and then the second thing is you will install the prerequisites. The third thing, you will install Tau itself, and then you will have your model working. So you will have your pipeline for training working. So as you can see here in this video as well, we started by pulling some Python dependencies. We have set up the virtual environment for the Python, and also we have installed Jupyter Lab, NVIDIA Python Index, and also NVIDIA Tau. Right now, this is a Tau installation. I've installed it before, so basically it was very short. Then after you have installed Tau, you can go to NGC again, the NVIDIA GPU Cloud, and you can download models, examples of how to work with Tau. Tau comes with a great selection of models and also a selection of notebooks, which allows you to use Tau TOOLKIT for faster. It gives you basically faster Kickstarter with Tau. So at the moment, we have downloaded the models and we unzip the files. We have downloaded the notebooks to start with, and we have unzipped the files on the virtual machine. And right now, we can start the Jupyter notebook, I think in the video right now. Yeah, 1 minute on top of our time, but we're going to finish very shortly. Yes. So we have started a virtual machine out of that, and also we have started a Jupyter notebook. When you can copy this link from the Jupyter notebook to your browser, and then you can find the notebook. The good thing about the notebook here is you don't need any coding experience at all to train a model with Tau, because the notebook shows you in a visual format how can you train a model. You can just get the notebook on the screen. I think I'm gonna push it on the screen right now. Yes, I have access. Yes, you have all the classes or all the models that you can work with. You can have notebook for body pose, FaceNet, GazeNet, HeartNet. So basically, all the models, faster RCNNs, Retina nets as well. So in this example, I'm going to show you how to use body pose. You start the notebook, and again, everything has been written before. You can have like a walk through the notebook, and also everything is runnable. You can run all the notebook, and you end up with training and optimization, and you can export the model to Deepstream, to TensorRT, which is going to be compatible with Deepstream later. To summarize, so this is how it looks on the video. To summarize, this is how can you start with NVIDIA Azure. First, you start the virtual machine, you mount the image, you SSH, then you set up Tau TOOLKIT, and then you download the models as samples, and you start to sample right away. This is Metropolis. I hope you have enjoyed that session. So right now we talked about Metropolis and how can we use it in Azure. There are different components. We can discuss these in so many sessions later, if that's possible as well. And finally, I'd like to there were a slide here that I wanted to have. Okay, I can't find it. So I need to stop sharing and look for it. Okay, so no problem. So if you want to start directly with Tau TOOLKIT right now, I have contacted our team, and they have provided me as well with code. So at NVIDIA, we have something we call it NVIDIA GPU, NVIDIA DLI. And yeah, I will just put up a slide very quickly out of nothing here. I'll put this, forgive me for this quick slide. DLI events. right. Again, to the cafe and share my screen again. Screen 2, share. Yeah. So please, sorry for this slide. It should have been better, but I didn't find the slide. So I've brought you this code. So please, if you can go, you can take a screenshot of this. You can go to courses.nvidia.com/DLI event. And then when you enter this Azure disaster November 2020 code, you will get an access to a disaster monitoring. I forgot the name. It's a DLI, so it's a workshop, a small workshop where you can have hands-on experience with Tau. You can have allocated virtual machine. Normally it's A100 GPU. And for instance, this one is hosted as well on Azure. So basically, you will not need to deal with the complexity of this, but this virtual machine is hosted on Azure for you. So please do that. Take this course. It's free for you and it's self-paced. You can finish it whenever you want. But this code is only available for today. So basically, it's for you. Again, take a screenshot of that. I also try to send it on the chat. If that helps, I think the chat will not reach every one of you, but maybe you can share it later if you want. So yeah, that's it. Back to you.
Yeah, like to say, and thanks for the code. DLI, Deep Learning Institute, is really a great resource for learning NVIDIA stuff, how to do things with their technology, like really nice things over there. And you can also, for some courses there, some are free, some are paid. For some you can get certifications, which is also nice to display knowledge about NVIDIA stuff. So, questions? Everybody is shy.
Yeah, I understand. I went through like a lot of tools, and I think I was faster most of the. So.
But what would your recommendation, Abu, be like for the beginners with NVIDIA technologies? Where should they start? Like, what to learn? There's a lot of things.
Yeah. So we have different couple of resources for developers. First one, as we mentioned, the DLIs. You can find a lot of cool free DLIs. The second thing, and that's also for everyone in NVIDIA as well, is our GTC conference. So the GTC usually has the latest and, yeah, that's a cliche, the latest and the greatest sessions. You can find a lot of sessions for the newest technology from our technology and also from our partner technology. And you also can have a lot of hands-on experiences. You can have workshops as well on the GTC. And GTC is always available online. So basically all of these sessions, you can have it on demand. This is the second source of learning. The third one will be the blogs. So every time or every day, there is a new blog from NVIDIA Pulse. It's posted on NVIDIA blog. And basically you can find it on different kind of topics as well. So these are the three main things. Then you can reach for us. We have a great team of solution architecture or solution architects who can support you in all of the sectors. We have people who can support you with computer vision workload, NLP, text analysis, speech recognition, also high performance computing, quantum computing, everything.
Regarding GTC conference, I think pre-corona, 3 years ago, it was here in Europe, in Munich, and I personally was there, and it's a really interesting conference because the expo area is not just taking place at the conference; it's also taking a lot of parking space out there. You can see self-driving buses and all the fancy cars out there. It was amazing experience. Do you know, maybe is it coming to Europe sometime soon? I know it will be in US, but will we have opportunity to see it again here?
I don't know about the new announcement for GTC because also I'm not sure about if it's going to be in person the next one or again it's going to be virtual. We usually have like two GTCs. The first one in the spring, which is usually in the States, and the second one is in Europe or in Israel in the fall.
So, I'll repeat the question.
Uh,
I'll repeat. So, question is like, if he has some device that doesn't have the NVIDIA GPU, how to use NVIDIA ecosystem?
yeah. For training is a very heavy operation. So if you're gonna do it with the CPU, it's gonna cost a lot of time. So Tau will not help you with that. But for deployment, we have Triton Inference Server, and Triton Inference Server works on both CPU and GPU. And you can host any model that you have if you have trained it with Tau, TOOLKIT, or TensorFlow, or PyTorch, or anything you can, or Onyx models. So basically, you can host everything you want with Tau TOOLKIT. Sorry, with Triton Inference Server. So Triton Inference Server works for everything else.
Like something running at the edge. Uh, yeah, I guess maybe a few words, Abu, about Jetson devices that would be. Uh, okay, new one is kind of expensive, but previous one it's super easy and super great tool for learning, right?
Yes. Well, the Jetson devices are very powerful in general. I think the Jetson Nano can run up to 8 streams for decoding, and maybe it can host one classifier and one tracker. It's gonna slow down like the bottleneck here is gonna be the classifier, so maybe you will not be able to use the whole 8 streams after you have decoded them, or maybe you'll need to go down a little bit on performance. That's that. Jetson Nano is the first one, but also we have the Nano Orin coming and announced. Right now we have the Orin devices, the Jetson Orin. The Jetson Orin AGX right now is as powerful as our T4 card, discrete GPU card. So it's really a powerful machine. So right now you can have a whole computer, like a full computer, as an embedded devices with Orin. The range of the Jetson devices ranges from nano to AGX. And it has also NX in the middle. So it depends on the workload that you have and also the seriousness of the application. It's going to be the main factors here when you choose the Jetson devices that you have, that you will use.
Basically, like Jetson, if I may put it in a in a bit different way, the way I see it, Jetson Nano is like Raspberry Pi on steroids. It's capable of running the models, and like with Deepstream, you can analyze 8 video streams in parallel. Like, yeah, so really great device to start developing on NVIDIA technologies and to learn that, to try it out. Price range for Nano was $99 US, which is not much, I believe. Yeah, the new one is, I think, 2,000. Not sure. Need to check online. 2,000 US. So it's a bit more expensive, but it's super powerful machine. So of course depends for your need, but Jetson Nano is definitely something you can try out. And there is also on DLI Deep Learning Institute there are some courses where you can get certification for that. And NVIDIA has huge developer community featuring projects from developers like what they build. And for some inspiration, I suggest you can check it out and see over there. It's really great examples from yeah, many different use cases, industries, and such.
Yeah, and that DLI for Jetson Nano is free as well, of charge. If you have the Jetson Nano, you can just start it with this. Yeah, in my office here, I have this Jetson Nano. It's a very tiny. And I also have the AGX, the Xavier AGX, which is connected somehow to this decent machine. Yeah.
Last question. No? Okay, thank you, Abu. We will take a short break now for the pizza, and we have one more session, starts at 1. I'm holding that session. Please don't run away after you eat pizza. I hope someone will stay. I promise I'll do my best. It will be interesting. So, yeah, that's it. Yep. Thank you.
Thank you. It's a pleasure to meet you. Please don't forget the code for the DLI because it will expire today if you didn't use it.